Hello everyone, this is Shanko and welcome to another video. So I wanted to make this video on Spring Web Flux module, and I'll be breaking down the whole thing into two parts. And in this part, which is going to be the first part, I'm going to talk about why we need Spring Web Flux in the first place and what problems Spring Web Flux is trying to solve. And in the next part, we're going to take a deeper look at the various components that we have in Spring Web Flux and how Spring Web Flux actually works. So let's get started with this video. So let's take a look at this code. So here we have a REST controller, and this is the endpoint that this REST controller represents. So we have this API/v1/student endpoint here, and we have this method here that caters to this request, or that basically carries out the internal working of this endpoint and gives the client a response, right? So here what we would essentially do is call the service layer. By the way, I'm typing with a broken finger, and that is why I'm typing so slowly today. My ring finger is broken, so yeah. Call the service layer, and the service layer is going to call the DAO layer. So this is the architecture that is normally followed, right? We have the service layer and the DAO layer, and then the DAO layer essentially talks to the database or the data source that we have, and then returns the result, right? So DAO would fetch the student record from the DB, right? So this is essentially what happens inside of this method, right? Now let's try to draw a picture and represent this functionality. So here we have the student service, right? We have the student service here, right? So this is essentially the endpoint that we have, right? So let's call this the endpoint, right? This is the endpoint, and any request would hit this endpoint. So let's have some arrows coming into this service as requests. So let's say we have four requests that are coming into the service, right, at the same time, right? And then we have a database here, and I'll name this database DB, call this DB, right? Okay, how do I drag this here? Oh, come on. All right, so we have the DB here, and this student service would use some driver, some JDBC driver or something to talk to this database, right? So let's put 4 arrows here to represent the connectivity between the service and the database. All right, so we have our picture ready. So whenever a request comes in, it essentially spawns a new thread, right? And let's say we have a Tomcat server is running this service. So in Tomcat we have, I think it's a thread pool of 200 threads. So at a time there can be a maximum of 200 threads that Tomcat can cater to, right? So whenever we have a new request that comes into our service, it essentially spawns a new thread, or it essentially comes in as a new thread, right? And this thread would make a call to this service, and the service would in turn make a call to the database, fetch the result from the database, and return a response back to the client, right? Return a response to the client. But this works perfectly fine, but there's one problem here. When we make a call from this service to the database, this can essentially be a time-consuming process. There is a connectivity that needs to be made from the service to the database, and then again, when the database does its job and returns a response, that has to be fetched by this student service, and then the student service would form the response, the final response, and give it back to the thread as a response to the client. So this part can become time consuming, and this part is blocking. So what do I mean by blocking? When this thread comes in and then the student service makes a call to the database, this thread would wait for the response to be returned by the database and the response to be returned by the service before it gets back to the client, and before it can be used by any other request, right? So this thread, until and unless it gives back a response to the client, it would keep waiting, right? So that makes this system a bit slower and a bit inefficient. So that is the main problem that we are trying to solve here with Spring Web Flux, right? So what we can do is, we can make, when a request comes in, the thread would it would come in as a new thread, right? And the thread would immediately become free to be used by any other request. And when the response is ready, when the response from database is available, the response would call back the thread, right? So this, what we have created here, is an event loop. What exactly do I mean by event loop? So a request coming in is an event, a database call being made is an event, a database response being available is another event. So all these things are treated as events, right? And this is basically an event loop. So basically, if we are talking about reactive programming, if we are talking about Spring Web Flux, we are talking about asynchronous event-driven non-blocking architecture, right? So when a request comes into the student service, it would immediately become available for any other. When a request comes into the student service as a thread, the thread would not wait for the database to return a response, but it would immediately become available for any other request and cater to that particular request. And when the response is available from the database, and when the response is available with the student service, the student service would make a call to the thread, and it would return the response back to the thread. It would return the response to the thread. Now there's a certain amount of complexity that comes in along with this architecture. So once we make a call, once a request comes in as a thread and makes a call to the student service, it doesn't wait for the database, right? It doesn't wait for the database to return a response. So when the response is available from the database, it has to give it back to the thread. It should be aware of which request the response belongs to. So these are the various complexities that are handled by the Spring Web Flux module that happened under the hood, and we need not worry about how we need to implement that, because that is already done by the Spring Web Flux framework. So that is basically the problem that Spring Web Flux tries to solve. It tries to make blocking calls, blocking API. It tries to convert blocking endpoints or blocking APIs into non-blocking APIs, right? So even if we have, say, one thread, we can even have just one thread catering to all services, because when the thread makes a request, it immediately becomes available. It doesn't wait for the response, right? It immediately becomes available for any other request to serve any other request, right? And when the response is available, a call would be made back to the thread, and the response would be returned, and the thread would know which client this response belongs to, and it would give that response to that particular client, right? So that is basically what Spring Web Flux is trying to solve. And in the next part, we're going to take a look at how Spring Web Flux actually works. We're going to write some code, and we're going to take a look at the various components and the various uh, uh, components that are provided by Spring Web Flux. So stay tuned for the next part. Until then, goodbye.